Hey Hernan, how are you doing?
Hey Dennis, doing good, doing good. How about you?
I'm doing great. We're live with this month's episode of Developer Office Hours. I'm happy to be here, and let's kick this off. So we have some announcements to make, actually. So let me share my screen. So there's this event called ZetaChain Summer 25, um, which is super exciting because it's an event both for developers and end users. It's starting this summer, so right about now. And for users, it's a learn and earn experience where you get to try new applications built on ZetaChain, of course, earn Zeta tokens, and get the latest alpha from all the apps and services being built on ZetaChain. For developers, it's a way for you to accelerate development of your application and get fit and scale your application. With ZetaChain, you can get different perks such as a grant, marketing support. Um, your project can be featured on Zeta Hub. You'll be invited to all sorts of events, both online and in real life, and of course on dev office hours. So pretty exciting stuff. To join, check out the grants page. So it's zetachain.com/grants. Apply now as a developer. For users, you can go to the Galaxy link. It's somewhere here. Let me see. Okay, just go to the blog and yeah, here it is. So galaxy.com/quest/ZetaChain, and you can learn more about it here. One of the projects that is participating is Pitch Lucy. Um, if you don't know, it recently launched its token, an AI-powered universal app where you convince an AI agent um, to buy tokens. Basically, it's a adversarial AI game. Very fun. Uh, Check it out. And yeah, it's now apparently it's #1 trending AI project on Dap Radar. Pretty exciting. So, okay, moving on. Um, let's let's start with the CLI. So yeah, during these DevOps hours, for those who's joining for the first time, we're just sharing things that we've built and that you can use as a developer to build um, all sorts of universal apps on ZetaChain. And right now, um, we have this tool, which I'm going to demo, which is hopefully going to really help devs to get up and running and quickly build exciting stuff on ZetaChain. So we released a CLI called, well, ZetaChain on npm, and you can open your console and type npm sudo, or without sudo, depends on your environment, but npm g install ZetaChain. I already have it installed, but you can install it locally, or you can run npx ZetaChain next. So both commands work just fine, and they're gonna uh, get the CLI running on your machine. So I already have ZetaChain. What this is basically a developer-friendly CLI that's, let me just move everything else cleaner. So it's a developer-friendly CLI that has a bunch of functionality that helps you build uh, universal apps on ZetaChain. So let's start with a command called new, which is what we are using in the docs. So if you go to any of our tutorials, like the first universal app here, um, you're going to see we're using the new command to create a new project. So let's do that. So ZetaChain new, and this will actually get all the, oops. Yeah. So this shows all the examples we have. You can choose, for example, NFT. We already have the directory here, but if you click yes, it will clone the repo, basically do some other things, and you now have an example. Let's create a project called Hello, which is our Hello World. Yes, so overwrite it, and now you can open it up. And here you go. You have a contract that is just basically a very simple universal app that you can modify and build stuff on top of. So very very convenient. And yeah, you can also create a swap project, for example. And so yeah, good stuff. Quickly up and running with all sorts of contracts on ZetaChain. Okay, so that's how you start. Just a single command, and you got a project up and running. Let's see what else we have here. So the next command, and by the way, Hernan, let me know if there are any questions. And yeah, if you
Yeah, so far no questions.
okay, yeah, if you want to add something also, because I don't see the UI for the screen sharing.
Yeah,
So.
I think it'll be interesting to start with the accounts command because I mean all of the other ones kind of ramificate from it, right?
Good call. Let's start there. So the accounts command is basically most of the commands that that you will be running depend on having an account with a private key. And this we have ZetaChain supports a bunch of different chains like EVM, Solana, Sui, Bitcoin, Ton, right? And all of these chains have different account systems, but you need a private key for any contract, for any chain that you want to interact from. So we built this system of commands called accounts that help you create, import, and basically interact with accounts on all these blockchains. So if you type ZetaChain accounts, it will show all the commands you have. One of them is list, and it will list all the accounts. I already have a few because, well, I don't want to share my private key even for test purposes. So I imported some of them. But let's say you don't have any accounts here. You can do create, execute the create command, and by default, it will create a default account called default, but you can pass any kind of name like Alice, and it will create a bunch of accounts in the .ZetaChain directory in your home directory. And now if you execute list again, okay, let me just make it a bit bigger. So you see that a bunch of accounts were added, and now you can use Alice account to send transactions from connected chains. So this is pretty good, but how do you actually do anything with this? Let's start with some of the commands that actually interact with chains like EVM. So, but before this, when you actually interact with with commands, you want to have a contract to interact with. So let's deploy an example contract to ZetaChain, and just so that we have a command contract that we can call. So we already created a hello example, right? We can just use that. Just type yarn, install dependencies, and should be up and running pretty quickly. Okay, so it's done. Now we can compile. For now, we're using Hardhat for compilation. We might switch to Foundry or even have our own CLI command for this. Not sure yet, but right now Hardhat. So we compiled the contract, and now we can use the built-in deploy task to deploy it to network Zeta testnet. This actually uses the gateway. Yeah, let's do that. I think the gateway is actually up to date. Okay, I actually need an account to deploy. That's one of the reasons we built the CLI, just so we don't have to deal with .env and accounts. Not to worry, I already have an example in. I mean, we can create a .env right now, but let's use an existing example contracts repo where I already have .env with my private key. Don't want to share that just yet. So hello, compile, same thing, same example, and deploy. So let's just check that the gateway is actually the gateway that we need on ZetaChain. So if you're new to building on ZetaChain, we have docs and we have contract addresses here. Just click contract addresses, and Zeta testnet has a gateway, and it's actually this address. So let's use that. Yeah, I was deploying it on localhost, so this is testnet, so the address is different. So this contract is super simple. It just implements on-call, which is a function that gets called whenever you trigger it from a connected chain like Ethereum, Bitcoin, Solana. What it does is it decodes the message. It expects to see a string there, and it emits an event with this string. Very simple. It has only gateway modifier to ensure that only the gateway on ZetaChain can call this contract. Okay, we have this contract deployed. Let's go to block scout. So ZetaChain testnet block scout. Just make sure that contract is there. It's there. Not verified, but doesn't really matter. I'm going to do it right now. So we have this contract deployed on ZetaChain, and we can now go into our CLI and try calling it. So for you to be able to call a contract on ZetaChain from a connected chain like Base, you need to have some tokens on that connected chain to pay for gas. Even if it's a regular no asset contract call, you still need to have some assets on a connected chain for gas. So we've built this balances command that uses the account system to query all the balances for your. Okay, so we have all the balances on all the connected chains, including Base. So I'm probably going to be using Base for this. I have 0.09 ETH on Base, which should be enough. So now let's call the contracts. ZetaChain EVM. We have some commands here like call. Actually, let's start with deposit first because it's simpler, right? Deposit command is just a command that deposits tokens from a connected chain to an EOA or contract on ZetaChain. And yeah, I'll make query balances again, just so I have my address. And let's send some base ETH from Base to ZetaChain using the deposit command. So we're going to be using the amounts flag to pass value, very small value.
You're using the default account, right?
I am indeed.
Okay, yeah, that's why you were not using the name argument.
Yeah, yeah. Um, I imported my actual private key with these tokens to the default account, but yeah, you can use. So let me just paste my address. By default, it's going to do name default, sort of like that, right? But if you imported your account as Alice, you would just pass Alice.
That's pretty smart. I actually have name Alice, for example, and I keep calling all of these commands using the name argument, but you just skip the entire step using the default account. Pretty smart.
Yeah, I'm just lazy. I don't want to type name, but I also have Alice, both Alice and Bob actually, because you often need to send tokens between accounts. So yeah, the
Good
whole
call.
team. But yeah, really good, good note on this. So I passed the address as a receiver, and the only thing I need is chain ID. So chain ID is the connected chain ID that you're sending tokens from. And for base, I'm kind of rusty on this, but 843. Okay, I don't remember.
I think it's 8452. Pretty sure.
8452. 8452. No, there has to be a 3 there. This is mainnet. I don't. So Sepolia base chain ID. It's 84532.
Three two.
Okay, we're very close. Okay, so with this command, it should create a transaction to send tokens from base to ZetaChain 0.001 native tokens to this address. I mean, this is the receiver address, and this is the address that is going to get a refund if something goes wrong, which it shouldn't because it's a simple deposit. So once that's done, it will return a transaction hash on base. At some point, we're going to improve this and actually print a Explorer URL with TX, but for now, let's just go to Sepolia base Etherscan base scan and find this transaction. So it has been included in a block, and we can see that the transaction is actually a valid gateway EVM gateway call. Eventually, just a few seconds. Okay, let's refresh the page. Okay. We can see that receiver has been filled out, revert address, call and revert is false. It's a simple deposit, don't need that. Board address, not gonna board, and revert message is empty. And yeah, so all the good default values are here. And what we did is we basically broadcasted the transaction on the base network on testnet. We called the gateway, EVM gateway on base, to make a deposit of some base ETH to my address on ZetaChain. So let's take this transaction hash and actually see if this transaction has been processed. It takes some time to do it, but yeah, it has been processed. So right now we're just using ZetaChain's API with this transaction hash, but yeah, we have a transaction tracking function, but it kind of needs to be updated to account for all the edge cases. So I'm going to be using API for now, but hopefully in the next release, we'll have an updated transaction tracking command. But yeah, you can see that it has been mined. And if we open up this address, my address on Block Scout, we will see the transaction. Okay, cool. So some base ETH has been transferred to my account on ZetaChain. Pretty cool. So just to recap, we executed EVM deposit command to send some ETH from base to ZetaChain to this receiver. And that's kind of like our goal with the CLI, is just to make this experience as simple as possible, right? Arguably, it cannot make it any more simple, right? It's just a single command, execute it, and that's it. So, okay, but now let's do something more exciting, which is calling a contract. We have deployed a contract to this address, and now we can make a call to it. And that's where ZetaChain really shines, is where you can like make a cross-chain call from a connected chain like Base to a contract, to universal contract on ZetaChain. So we're using the call command. It doesn't have an amount parameter because it's a no asset call. So you're just making a contract call without any assets. You are paying for fees, but that's it. So for the call command, we will be passing types and values, and it will encode, the command will encode it automatically as ABI. So let's pass types. And these are just ABI types like string. Our contract expects a string, and values is just a list of values. So we're going to say hello. Let's change the receiver to our contract address and keep the chain ID base. Is that what we want? I think that should be it. Let's check. Okay, call and revert false. Function parameters hello. Parameter type string. Looks good to me. Okay, so the transaction has been broadcasted. Let's give it some time to actually process the transaction. But in the meantime, we can see some of the other
I
options
wasn't
that we have.
expecting it to go that fast. I mean, that was almost instant.
Yeah, well, I'm being very sneaky, and I chose base for purpose because it's very fast.
Good call,
Like I could
good
have
call. But I
chosen.
mean, that was immediate.
It was. The demo gods are
So far in
blessing
your
us.
favor. Yeah, yeah, yeah.
Yes. Okay, so let's see if that is also successful. Okay, that takes a bit more time. Let's actually see if it has been included in a block. Okay, it has. Let's give it some time. But yeah, in the meantime, there are other options you can use. We're not going to go into details right now, but basically, when you're making a call to Universal App, it could revert, right? The contract on ZetaChain can throw an error, can revert, and you want to handle this. So you can pass call and revert function which will do the following. Basically, when you're making a call and the contract on ZetaChain reverts, the ZetaChain protocol will actually make a call back to the chain from which this contract originated, which is Base, and it will call a contract on your behalf that you specified in the revert address. So it can be the same contract from which you're making a call, or it can be a different address a different contract that is specifically built to handle reverts. So that's also possible. By default, if you didn't pass call revert, what ZetaChain will do is it will send the tokens that you've deposited to the revert address. If the revert address is empty, it's just going to send it to your own address on the connected chain. So from which you called the gateway in the first place. So this is basically a refund. This is not available for call command because it doesn't send any assets, but it is available for deposit and call. For calls, you might want to specify the revert address and specify call and revert as well, just so that the revert scenario is handled gracefully on a connected chain. You can also specify gas limit. So because when you're passing call and revert and ZetaChain execute server, it needs some gas to call your contract. So you can set the gas limit, and that affects the amount of tokens you actually need to supply for this call to succeed. So let's go back to our transaction hash. It has been mined, of course. And yeah, we can go to our receiver. Where is it? Okay, it's this contract. Open up here. It's not verified, but we can still go to the logs and see, yeah, it has emitted an event. So we just deployed a contract on ZetaChain Universal App that we called from base and it emitted an event. So yeah, pretty cool with just one command on the CLI, the way it should be. And of course, you do deposit and call as well. So this kind of combines the powers of these two commands where you can pass an amount and also types and values. So it will send the amount of ETH as well as a message, which is hello. Your contract will receive amount as ZRC20 ETH, which is the token representation, which is a token that represents the asset on a foreign chain like Base. So go back to the contract, you can see that on-call has this ZRC20 address, which will, if you're using deposit and call, it will be filled with the Base ETH ZRC20 address and the correct amount, and you can handle it. For example, you can swap the token or you can do anything you want with it. The cool thing about ZRC20 tokens is that you can send them from connected chains as well as withdraw them back to connected chains, and there are liquidity pools with ZRC20 tokens. So it's just a very convenient token standard that you can use, that you should actually use when transferring value and calling universal apps from connected chains. And you can check out the docs, of course, to see all the ZRC20 tokens that ZetaChain supports. So a bunch of tokens from all the connected chains. And the cool thing is that all of these tokens are ERC20 compatible, even if they're coming from Bitcoin or Solana. They're all represented as ZRC20, ERC20 compatible token on ZetaChain. So it's very easy to swap tokens or just interact with them. They act as representations of tokens from connected chains. Okay, so we covered deploying universal apps, balances accounts. We called a contract from Base. We deposited some tokens. Let's see, what else do we have? So ZetaChain. So we have some commands for ZetaChain, which is very similar to what we have on EVM side.
You can also use the alias set instead of the entire ZetaChain word.
Yes, that's a very handy, because you don't want to type too much. You can, just use ZetaChain Z call or withdraw. And this makes a call to a gateway on ZetaChain, which on your behalf will either a call contract on a connected chain like Base, or it will withdraw tokens, withdraw and call. So it's basically like a mirror image of EVM commands, where on EVM you have deposit, and on ZetaChain you have withdraw. So let's try to withdraw some tokens. It needs a ZRC20 option, so you can specify the ZRC20. I think I have some, I should have some ETH, base ETH, and receiver, again, is just my address. Here it is. And I think that's it. Like, we don't need to provide any other arguments because the chain is
the
just
amount.
ZetaChain. That's a good point. I do need an amount. Otherwise, it's not going to know how much to send. Okay, thanks, Fernand. So you provide an amount, and all the values are correct. Just press OK. And it's going to broadcast the transaction on ZetaChain. Give it a few seconds to actually include in a block. See if it works. It does. Now we can go to Block Scout. You see this transaction. You can use the same API endpoints. to track this transaction. It's already pending outbound, hasn't been processed yet, but it's going to be processed pretty quickly. ZetaChain instantly recognizes a transaction, outgoing transaction. So let's give it some time to be processed. In the meantime, the withdraw and call command is very similar. The call command is almost exactly the same. You pass types and values, contract address, and that's it. It's going to call a contract on base. We might demo this if you have time. I just want to leave some time for other things, but for you to try this at home, you can go to the call example here, where we have contracts both to deploy on ZetaChain called universal as well as connected. So you can deploy this contract to base, for example. I don't think I have .env here. So yeah, I'm not going to demo it, but you can run npx hardhat deploy network base deploy, I think the name of the network, and name connected. So this is going to deploy the contract on base, and then you'll be able to call this contract using ZetaChain CLI and just pass types and values, and it's going to just work. So let's go back. Okay, it has been processed. Open mind. This chain ID. We have transaction hash. Let's go back to the base explorer, and we can see that the amount was transferred from the gateway. Well, actually, it's a TSS address, but to simplify, from ZetaChain gateway address to the recipient, the amount is the same. So yeah, it's pretty cool. We just withdraw some tokens from ZetaChain to base. So you can use the CLI to interact with the contracts, to just do some testing. Like if you need to have some ERC20 on ZetaChain, you can quickly use EVM deposit, send some assets. We actually support ERC20 tokens as well. Not as a flag here, but oh yeah, here it is. I don't know why it's not showing. It's the last flag here. So yeah, you can send not only gas asset, but also supported ERC20 tokens. And yeah, super convenient. Okay, I think that covers that. What else do we have in the CLI? We've covered EVM, ZetaChain. Well, no local nets. I think if you're building on ZetaChain, you're probably already familiar with local nets. It's a environment that runs on your machine that starts ZetaChain on a local Anvil instance with a few other EVM chains, as well as optionally Solana, Sui, Ton. And it's very convenient to test your contracts there. So you can run ZetaChain local net start. You can specify, by default, it's just going to run with ZetaChain and EVM chains using Foundry CLI under the hood, but you can specify chains like Solana, which, yeah, I meant chains. You can start local nets with EVM chains and Solana, and it's just going to do all this setup stuff, and you will have both ZetaChain, EVM chains, and Solana running locally, and contract addresses and all, and you can deploy your contract there. Let's actually do this. So we've already compiled. We can now deploy localhost, and the contract address on ZetaChain here is here. So yeah, this just deployed a contract on local nets, and now we can interact with it. And yeah, it's a very fast way of kind of building stuff. We have in every example, we have a script called localnet, which starts localnet, as the title suggests, and runs a bunch of commands that interact with this contract. So you can think of this as kind of end-to-end testing. And I strongly recommend you have that for your application where you're building, because it just helps you verify that it's working. You can run it in CI, as we do for all examples, and you can also run it on your machine locally. So local nets is there in the CLI, cool stuff. And we also have Bitcoin. So let's dive into Bitcoin. So ZetaChain is known for its wide variety of connected chains, both EVM and non-EVM, and Bitcoin stands out because not many other blockchains are natively connected to Bitcoin. So we're super excited to bring Bitcoin support to the CLI. Bitcoin is tricky. It doesn't have smart contracts, so the interacting with Bitcoin is very different from interacting with EVM chains. So what we wanted to do is simplify this process and make sure that when you're building universal apps and you want to interact with them from Bitcoin, you have all the tools you need to do so. So ZetaChain supports two mechanisms of interactions from Bitcoin. One is inscription, and the other one is memo. They're very different, both in implementation and how you end up using them, but both are available. Rule of thumb is if you just want to deposit some tokens, you can get away with just sending a transaction with a memo. Or if you want to make a call with just a small message, up to 60 bytes. So if that's all you need, you're probably okay with using a memo, which under the hood uses OP return. If you want to send a message that is longer, or if you want to send a transaction that handles revert addresses in a customized way, then you're better off with inscriptions. So by default, when you're sending a memo transaction from Bitcoin and the call reverts, it will send BTC back to the sender address on Bitcoin, which is probably what you want. But if that's not the case and you want to specify a custom address as a revert address, then you should be using inscriptions. So let's dive into inscriptions first and see how to use them. So Bitcoin inscription. And you see familiar commands here, right? We have call, deposit, and call, deposit, and we have encode just to help you encode data for as your payload. So what we can do is we can mimic the same. Well, first of all, let's actually call the deposit just to send some tokens. So deposit needs inscription deposit. It needs an amount, right? So let's send a very small amount of BTC. By default, it uses Signet, which we support both testnet4 and Signet, but personally, I recommend Signet because it's faster and more reliable. Probably easier to get testnet tokens for Signet as well. So amount, then we need a receiver. A receiver is an address on ZetaChain, which is just going to be my own address here. So copy and paste my receiver. And I think that's it. So by default, it's going to use.
I don't think that 0.001 is a small amount by any means, though.
Yeah, but keep in mind we're using testnet, so
yeah, sure.
yeah. So let's try sending this amount first. I'm not actually losing this amount of BTC. I'm sending it to my own address, so it's not wasted. I can always withdraw it back. But yeah. So here we can see all the fee breakdown. This is the amount of sats we're sending. This is all the different fees we have. So basically, the way inscriptions work is you need to send two transactions. One is called commit transaction. The other one is reveal transaction. And in commit, you include the data. In reveal, you kind of reveal it. Basically, both two transactions are required, and they both require fees. So again, this is testnet Bitcoin, so don't be scared of these amounts. On mainnet, it's going to be different, and it calculates the amount of BTC in total. Uses the default gateway address on Bitcoin. Receiver revert address is my own address, which is good. And operation is deposit, and it also shows raw inscription data. And this looks good to me. So it broadcasted two transactions. Now we can go to our Explorer mempool space and open up the first transaction and check it out. So yeah, it's not very descriptive here, right? But just it doesn't say commit. It just says segment taproot transaction. But yeah, let's take a look at the other one. Hopefully a bit more descriptive. So yeah, it says inscription, and this should actually show the data we're sending, so all the push data. I don't know about you, I can't read this, but
No one can.
Some people might. So I see this address, and it's my address, and yeah, so looks good to me. We're not going to wait for this transaction to be processed because it takes like 3 blocks. But yeah, once it hits 3 blocks, you can use this transaction hash from the reveal transaction, not the commit one, the reveal transaction, and use it in the API. And it's going to show you the transaction that you made. I actually think I have some transactions that I made earlier today. Token transfers, BTC. So yeah, so I transferred some BTC just 4 hours ago. So you would see basically the same thing here, where BTC, 0C20 BTC from Signet is transferred to your account. So that's super easy, right? We just transferred some BTC to ZetaChain, no big deal. But a more exciting, again, command is call. A call command lets you broadcast Bitcoin transaction that actually calls a contract on ZetaChain. And this is also accomplished through inscriptions. We put all the call data inside the witness section of a transaction, and it is recognized by ZetaChain, gets processed, and your universal contract is called. So let's try this. The call doesn't need an amount, but it needs types, exactly the same way as we did on base. Type is string. Of course, you can pass like string, uint 256, boolean, all that jazz, right? You can pass all sorts of things here, but our contract expects a string. We want to keep it simple and say hello from Bitcoin. The receiver is going to be the contract that we deployed. Let's find it here. And we deployed it on localhost. Yeah, here we go. Yeah, I think it's that. So using this contract as a receiver, I think that's it. Okay, provider, the data types, receiver, and revert address. Yeah, it actually needs a revert address. This is probably going to change in the next version because I think we should just pass receiver address by default. The sender address as the receiver unless you specify a revert address. Okay, so let's check. Amount 0 BTC. Total is still 18,000 sats. And encoded message is this, which is flow from Bitcoin encoded in hex. And this is the raw inscription data, which we actually can check on mempool later once we broadcast. So let's do it. Okay. Commit transaction is not very interesting. There's kind of nothing there really. So let's just skip that and go directly to the reveal transaction. And it has been included. I mean, it hasn't been included in the block, but you can already see it. So this is the push data, and it should match what we have here. If it doesn't match, it's a problem, but it matches exactly. So this is good. Means that we're going to be calling this contract with hello from Bitcoin, and yeah, that's how easy it is to call universal app from Bitcoin. Literally just one CLI command.
I guess
Super
that also
straightforward.
generated, I mean, that also emitted an event on the universal contract, right?
It will emit an event as soon as it's processed, but it's probably gonna, like on Signet, it's probably gonna take like 10 minutes.
Okay.
You could have done this in the beginning, and by this time it would have been processed, but we can always do it next time. And I
Yeah, for sure.
encourage you guys to check it out. It just takes like 4 commands in total, right? You clone a contract with ZetaChain new, compile, assuming you have some tokens already, then you just call deploy and ZetaChain Bitcoin inscription call. That's it. So let's check out. So deposit and deposit and call is the same. It just combines the two. The encode command is useful because sometimes you need this inscription data because you want to use Unisat, for example, or some other wallet, and you want to send inscription manually. So what encode allows you to do is actually do the same thing basically. Can take a call, do encode, types, values, receiver, and it's just going to return the same value that you can take and put into your wallet of choice that supports inscriptions and send it manually. It might be useful on front end as well because you're not going to be using a command there, so you can just use the output of encode and do it there. We're going to have more helpful commands shipped with the toolkit, so on the front end you'll just be able to import all this functionality and call Bitcoin inscription deposit. But yeah, for now we made it really easy to call these functions from the CLI. One more thing I wanted to demo is the memo. Demo the memo. So we have all these commands in the memo namespace as well. And the difference between inscription and memo for simple deposits is that with inscription, you have 2 transactions to process. With a memo, it's just 1 transaction, so it's cheaper. But for most scenarios, if you're passing data from Bitcoin, you probably want to use inscriptions. But yeah, for simple deposits, you can use memo deposit, and it will. Let's actually use the same deposit, but instead inscription, we do memo. And yeah, you can see that there is a deposit fee, network fee. It's much lower than what you would get with inscriptions. So for regular deposits, memo might be the way to go. The deposit fee is actually something different on Bitcoin rather than like on EVM, we don't have deposit fee. On Bitcoin, we do, simply because when users withdraw tokens on Bitcoin, so Bitcoin account system is different, right? There are UTXOs, and there are costs associated with sending BTC from different UTXOs, right? If you have to split tokens, if you, I don't know if you heard this noise. Hope you didn't, but mempool, when it makes a confirmation, it produces a very unsettling sound. So I'm just gonna
I couldn't hear anything.
let's try it. It's super disorienting when you're waiting for a transaction to be processed, working on something else, and then this like loud sound in your headphones from mempool. Absolutely terrifying. Anyway, going back, the deposit fee is needed because the protocol has costs associated with sending tokens from users when they're withdrawing. So this is an amount that we charge that goes into the protocol to essentially facilitate withdrawals and deposits from Bitcoin. So let's broadcast. You can see it's only one transaction hash mempool going here. So it's just one transaction, doesn't say inscription, and the OP return contains the receiver address. It's actually less readable than inscription because it's not even hex, but here it is hex. So this just sends BTC from Bitcoin to this address, and we support both methods. Check it out, see what works best for your use case. Most likely it's subscription, but it's simple deposit. Use the memo, and you can use call as well. It requires another param called data. So this is different. One more difference between inscription and memo. In inscriptions, we default to ABI encoding because we can, right? Because inscription allows you to send more data. So we can format it in a way that is very easy to parse on ZetaChain. However, we can't do that with OP return. Well, technically, we can encode as ABI, but it's going to be longer than what OP return allows us to send. So we just disabled this altogether. So you have to send the data manually like so. And the most you can send, I'm just kind of sending my own address here, but 3 addresses is the max amount of data you can send. For deposit, for call, we actually don't have amount. I'm not going to call it, but yeah, you can see that this is going to be the memo. In total, it's 80 bytes, but one is reserved for the receiver, the rest for the data. So yeah, you can check it out. It's cheaper and it might work for some kind of simple use cases. Cool. Well, let's see if we have anything else. We have a Solana namespace.
Sorry, I have a question before you move on. So in
Yeah.
Bitcoin, we have both inscription and memo. The thing is, I mean, you said that memo is not recommended for transactions with big payloads, but I noticed that we have memo. In memo, we have deposit and call. I mean, I would like to have your comment on whether it is advisable to use memo deposit and call, because I mean, usually when you call deposit and call, the payloads tend to be bigger.
Yeah, it's the same story as with a regular call. You only have 60 bytes that you can send. So this translates into 3 EVM addresses. So that could be like 2 EVM addresses and maybe a uint or a Boolean, right? And you have to concatenate them yourself this way. So let me put it this way. The payload limit is a hard limit. You can't go above 60 bytes. So that's the max amount of data you can send. That's one downside. The other one is that you have to concatenate it manually. You can't use ABI because ABI is just going to fill the whole thing with zeros, right? It uses padding. So maybe you can send like one integer, but that's it. And that's actually not very convenient on the universal contract side, because if you go back and check out universal contract below here, it's EVM, it's Solidity, right? You have ABI decode. If the message is coming from Bitcoin, then you need to, from Bitcoin using OP return, you manually have to decode it. You can't use ABI decode. For example, right now we have the swap contract, which is compatible with OP return, and this is what you have to do. You have to use either helpers, or you have to loop through the bytes manually. Not something you want to do really if you can help it, right? So this is the stuff you have to deal with if you're using OP return. It's not a deal breaker for some applications. You really want to make sure that it's super cheap for Bitcoin users to send um, uh, value and data. You can do it. It's not rocket science. But it's also not developer experience that you kind of want to have, which is just ABI decode. So with inscriptions, you can use ABI decode, and that's it. So the same contract, the same exact contract on ZetaChain, like we have here, is going to work out of the box, both with EVM and Bitcoin. And I think that's really powerful, right? Fewer bugs. You don't have to parse the payload yourself, but if you want, you can. And yeah. Did
That
that
makes
make
sense.
clear? Okay,
Yeah, that makes sense. Thank you.
cool. Um, we have a Solana namespace. We don't have much there. We just have an encode function. I'm not going to go into details right now because basically in the next release, we're going to have all the commands you will ever need in the Solana namespace. So call, deposit, deposit and call, all this, include and encode, of course. And we're going to demo this. I think it's going to make much more sense with all the commands here. But yeah, we already have this. Basically, the encode command is a command that encodes payload for ZetaChain call or ZetaChain withdrawn call. So you can make an outgoing call from ZetaChain to program on Solana. So yeah, we're going to cover this in the next dev office hours. I think we covered quite a lot. Let's see if we have any other commands. I don't think we do. Yeah, I think we covered
Yeah,
everything.
I think you covered all namespaces.
Cool. Well, just to recap, we now have a very cool CLI, very pleasant to use. Just install it with npm or use it directly using npx. It's going to have all the commands you need. We're going to be adding Sui, Ton, and Solana support next with some other commands as well. And just making development easier. If you have any suggestions, of course, it's all nice open source here. There's a CLI. You can create an issue here. You can create an issue in any repo, really, toolkit, whatever. Just click new issue, type a feature you want to build, you want us to build, and yeah, we'll take a look and let's make the CLI better together. Cool. Well, I think that's it from my side. I think it was a pretty long presentation. It was like an hour, right?
I think it was a complete hour, but it was super comprehensive. And I mean,
Thank you.
thankfully, there was a lot to show to users because I mean, we've been shipping and building quite a lot. So, I mean, thankfully, this was full of goodies.
Yeah, really looking forward to feedback from users. Because yeah, it's always better to get real feedback from developers using this stuff. It's all very new, of course, so please don't use it on mainnet just yet. We need to make some improvements, additional checks, and all that. So yeah, please use it responsibly for testing right now. But eventually, the plan is to actually make it fully mainnet compatible and maybe even audit it at some point. So that would be like a really really nice CLI have where it's like compatible with mainnet and users can use it with real tokens, but don't do it now for now, right now. Okay, well, I don't think we have any questions. Let me check Discord. Yeah, okay. Think any questions there? Okay. Well, we are available as usual on Discord and Dev Channel. Check it out, zetachain.com. There's a link to our Discord server. I'm happy to answer questions there. And thank you so much for joining. Thanks, Renan, and everyone else.
Thanks, everyone.
Goodbye, guys.
Bye.